Hey, it's Jacob. Welcome to this video where I'm going to give you 5 tips to make programming easy to learn. Specifically, you'll learn why understanding everything can be harmful when it comes to programming, how the trial and error process makes everything you do easier, how to encapsulate what you don't know, how to be in the zone when programming, and how not to solve your own errors. So you might be thinking that programming is too difficult, like this is not for you, you're just not good enough for it. There are people that are good at math and there are people that just aren't. And the people that aren't should do something else. You might have even tried it for yourself and give up because you didn't have any results and you put in a lot of efforts for it and it just didn't work. Or you might even have found people around you that are not that smart and they learned programming and they didn't find it that difficult. How is that possible? You might even feel angry about it. Why is it I feel like I put on a lot more time and effort than I should? Well, if that's you, then it's not your fault, because the educational system is partly to blame on this one. Because at school, we're taught about the purpose of a command line when we learn programming, how that command line works. And so the goal is to understand every details about that command line before we move on to the next one. So this is just an example of how they make the learning process more difficult than it should. But in general, we're not taught how to learn practical and useful things or trained at acquiring a skill quickly and painlessly. Instead, there is a huge emphasis on understanding the causes of the effects. The problem is that's not really how it works in the real world, because in the real world, understanding has a cost. And in the context of learning programming, the cost is time and willpower depletion. So the point is, it's not our fault. The way the educational system is approaching learning just doesn't work. So this brings up to tip number 1, focusing on understanding less. Notice that I didn't say focusing less on understanding because it has to be a proactive effort before it becomes the default. Understanding everything will slow us down. We don't need to know how it works. We need to know how to use it. For example, I have no idea how a phone works, but if I dial a phone number, it will somehow reliably contact the person I want to get to. I don't need to know the black magic happening behind the scenes to master my phone. In fact, what do you think? Would it make us better at using our phone if we understood electromagnetism? I doubt it. And the reality is even worse, because in the real world, our time is limited, which means if we have an hour to learn how to master a phone and we spend half an hour learning how to use it and half an hour learning how it works, then we'll be a lot worse off than somebody who spent the entire hour learning about how to use it. So the point is, slowing us down would not be a problem if it wasn't a zero-sum game, but it is, because the time we invest in one thing, we don't invest in another. That's actually one of the most frustrating mistakes people make when trying to learn anything. They get stuck on complicated details that don't matter. In this case, less is more because learning something difficult to understand and which doesn't bring much value is not just a waste of time, it also depletes our willpower. And not managing our willpower when learning a new skill is the fastest way to get discouraged and overwhelmed and just give up. Tip number 2. Using the trial and error process. Believe it or not, a big part of programming is actually trying things and see if it works. That means we want to get used to do a lot of copying and pasting and tweaking the code until it works. But it's not about directly adapting the code to what we want to do. It's about gradually converging towards what we want to do. The process goes something like this. Step 1, you copy and paste the code from somewhere you found on the internet or wherever. Step 2, you run it without modifying it. If it doesn't run, either you find another piece of code or you debug it. If it does run, you tweak one single thing in the code and run it again. And then you see if it still works. The goal is not to adapt the code yet. It's to figure out what can be modified in the code without having to think or understand it, and without creating errors. It's basically figuring out how much wiggle room we have to play with the code without breaking it. So if it works when we tweak one part of it, great, we can take a mental note about it. If it doesn't, great, we can take a mental note about it also. Then, based on the information we gathered this way, we can decide if we can get there or if it needs more investigating and more tweaking. Notice one thing if we follow this approach. At no point do we even try to understand the code. As the process unfolds, we get better at using the code, not at knowing how it works. As humans, we're a lot smarter at doing than understanding. The main point is, if we want to understand something, then we need to learn how to use it first. Then we can work on understanding it. If we reverse the order, we make it 10 times harder. Third tip, encapsulating. In this video, I'll talk about encapsulating to describe the process of 1. Defining a function from several lines of code. 2. Defining the interfaces of this function as a way to restrict its use so that it makes it a lot easier for us to manipulate. For example, if we find lines of code on the internet to extract the content of an Excel file, but we don't understand the purpose of every command there, then we can use the process of trial and error described earlier to figure out how to use it and encapsulate it as a function that we call extract Excel file. Then we could define a single input argument which would represent where the Excel file is located. If we do that, then we truly don't have to look at the code encapsulated in that function ever again. The point is, if we know how to use the function through trial and error, then we can make it easy to use even if we don't understand what's inside by simplifying and clarifying the way we'll use it through the interfaces that we define. Since we're the one defining the interfaces, we can make them as clean, simple, straightforward, and unsophisticated as we want. Fourth tip, using the run button more often. One of the main reasons why a lot of people take a lot more time and effort to learn programming than needed is because they don't run their code often enough. This seems simple, but running the code we developed as soon as possible is the best way to make things easier for us. Because 1, we prevent mistakes from accumulating. The earlier we test our code, the better. Because the longer we wait before testing our code, the more difficult it's going to be to correct the mistakes we've made. 2, we small chunk the process of creating a program. It becomes a step-by-step process where every step consists of either researching the code that does what we want or developing the code. Creating an entire program is not easy, but creating a single step is. 3, it gives us feedback on how we are doing. There is a book called Flow by Mihaly Csikszentmihalyi, which explains the psychology of getting into a flow state. One of the main takeaways of this book is that feedback is a major component of getting into that state. Now, how can we make sure that we're going to run the program more often? How do you make that tip more practical? By ensuring we have 0 manual interventions between each time we run the code. For example, if every time we run our program, we create a copy of a file, being an Excel file, a text file, or whatever it is, then we need to manually delete that file after each run. Instead, we could automatically delete that copy before each run if the copy exists. It's a simple if statement to add at the beginning of our program, but it reduces the number of manual intervention between every run down to 0. It doesn't seem like a lot, but I guarantee you that consciously or unconsciously, you'll use the run button a lot less if you have to manually do something every time you want to run your program. Tip 5. Not solving errors. When an error is not 100% obvious, we sometimes tend to try to solve the error ourselves. The problem is it's a waste of time and energy because even if we succeed, it's slower than copying and pasting the error in a favorite browser and let it solve it for us. It's more efficient and easier to do than solving it ourselves. I can't count the number of times when I forgot about doing this. This tip is especially useful when we start because then it's more likely to have errors that we've never seen before. And trust me, it's a lot easier to solve an error when we already have solved it in the past because we have examples. But when we've never seen the error before, then we can still have that set of examples being solved for this specific error. But it's on the internet, not in our memory. It's basically a way to cheat our way into having more experience than we have. So the problem with all those tips is that there are ways to do it right and there are ways not to. And if you don't do them right, you could actually put in more effort for even less results. And that could make things even more difficult, which would defeat the very purpose of those tips. Or it could take you a long time to get there. That's the reason why I created a free online course to help you avoid wasting time and energy. You can click on the link in the description to get it. So now that you know that learning programming can be easy and painless, you might be wondering if you should invest in yourself to make the process of learning not just easy but also fast, or if you should save your money. I'll talk about this in the next video. Have a great day and see you in the next one.